today's topic, which we are going to discuss in continuation of our previous topic, that was isomerism. And now, after isomerism, our next very important topic regarding alkanes, that is cracking. What is the meaning of this word, cracking, and why we perform this process in industry? Actually, cracking means breakdown. So, breakdown of large molecules, as the name indicates, cracking. So, breakdown of large molecules into small fragments, right? This is known as cracking. Actually, why there is a need of cracking? So, the main source of these alkane molecules, that is actually petroleum. So in petroleum we get different types of compounds. For example, for understanding, let's take the example of octane. Now, what is actually octane? Octane has molecular formula C8 and H 18 C, and according to the general formula of alkanes, CnH2n and plus 2. Is it clear? So octane is one of the compound which we get from petroleum. What is actually petroleum? Petroleum is a source of these organic compounds in the earth crust, right? So we get mixture of these organic compounds from the petroleum, and one of them is an octane. Now, octane is used as a petrol in our cars. Okay. So due to this, it has a huge demand in our daily life. But let's say the petroleum, which is the natural resource of this octane, suppose that 80% of our demand that is fulfilled from the petroleum. But what about the remaining 20% of our demand? So how we can fulfill this demand? Actually, you can say that the 80% of our total demand in the world about petrol, that is fulfilled from the petroleum. What about the remaining 20%? So to fulfill this demand in our daily life, so what we do, we take those molecules which are even larger in size than octane, but they are of less use. For example, let's say I have this molecule C10H22. It's a decane, suppose. So now this decane is also obtained from the petroleum, and its demand is just, let's say, 10% of it is used in our daily lives, while the remaining 90% of the decane which we get from the petroleum, that is of no use. So we have to make it useful. So what we do, we take that molecule and we break down into the smaller fragments, and this breakdown of larger molecule into smaller fragments, that is known as cracking. For example, if I have a decane molecule and I break it down into two small molecules, C8 and H18, and then C2 and H4. So this one is octane, and this one, C2H4, is an alkene, which is called ethene. Now, you can see here we are getting octane again, and we need more octane, right? So this fraction, which was of no use, or 90% of it was of no use, so we broke that decane molecule into a more useful product, which is octane. And even ethene, that is also a useful compound, which we will discuss later on in the manufacture of an alcohol. So these are more useful compounds. So we can say here that cracking is a process in which we break down large molecules into small fragments, or I will add one more word, the breakdown of less useful large molecules into more useful small fragments, right? That is known as cracking. So, how can we practice these types of cracking reactions? Let's take this example. So, C10H22, I am drawing its structure, the decane molecule 3, 4, 5, 6, 7, 8, 9, and 10. And remember, it's an alkane. Why? Because all have carbon-carbon single bonds. Now, for cracking means to break down. So it means we can break this large molecule into small molecules in different ways. I just took one of the example. Here, I broke it into two parts. So I broke it into two parts. Here, one of the fragment of two carbon atoms and another fragment of eight carbon atoms. But that's not necessary that it will break down into two smaller molecules. It can even break down into other molecules as well. For example, you can break it from here as well. So in that case, how many molecules I will have? So this one of six carbon atoms, a two carbon atom, and two carbon atoms. So this is another possibility. So if I break it down, so remember when alkane break down, it will give us one of the molecule as alkane, which is of six carbon atoms, 3, 4, 5, and 6. The another molecule is also of two carbon atoms, and this third molecule that is also of two carbon atoms. But here, remember one thing, we have to balance the reactants and products. Number of carbon atoms, they are balanced, but we have to balance the hydrogen atoms as well. For example, look at this here, how many hydrogens we had. So 10 carbon atoms, and we had 22 hydrogen atoms. So when I broke this down, so I will get this product here. How many hydrogens? 3 and 2, 5 and 2, 7 and 2, 9, 11, 13, 14, and 15 and 16, right? So 1, 2, 3, 4, 5, and 6 carbons. So 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So C6H14, right? So it's an alkane molecule. But this another molecule, let's say if I make it alkane 2, 3 and 3, 6. So 14 and 6. Here I had 22 hydrogens. So if I made this one an alkane as well, so how many hydrogens are left? Only 2 hydrogens are left. So that is not possible. This one. Only 2 with the third molecule. So what is the possible product? Here you will have 2 hydrogen atoms and the another product. Here you will have carbon carbon double bond. This one also double bond. Now you can count the number of hydrogen atoms as well on the left hand side and the right hand side. So here its molecular formula C2H4, C2H4. So total carbon 6 and 2 8 and 2 10, and the hydrogens 14 here and 4 18 and 4 22. So it means that hydrogens and carbons they are balanced now. So remember one thing, when you use alkane and break it down, it will break down into alkane and alkene molecules, right? So if you break down into three molecules, so one of them will be an alkane and the another two should be alkene, then it will be balanced. Otherwise, it will not be balanced. And there is another possibility as well. If you crack an alkane molecule and you draw only alkenes, right? So in that case, the other byproduct will be H2. Only alkenes. Alkenes are those in which there are carbon-carbon double bonds. Now let's try one more example. Suppose I have this molecule C16 and H34. It is an alkane. How can I say that it is an alkane? Yes, 16 into 2, 32 plus 2, 34. According to the general formula of alkane, CnH2n plus 2. So it is alkane, and now I want to break down into smaller fragments. So suppose I give you this one, let C6H14. Hmm, right? And another one of the product that is, let's say, C4H8, right? And then C2H4. How many molecules will form? Let's say one is here, one is here. Now I want to balance the equation. How many carbon atoms I took on the left hand side? Here there are 16 carbon atoms. And this one is a blank, right? So 6 carbon atoms here, 4, 6 and 4, 10. And now remaining carbon atoms, they are 6 because total 16 on the left side. So I have to multiply this one with 3 because this one is given in the balanced equation. That was the blank. So total carbon atoms on the right hand side, 3 to the 6 and 4 10 and 6 16. So let's check the hydrogen atoms. So 14 here, 8 here, and 3 into 4 12. So 24. So it's a balanced equation. So these type of questions can be asked. The 3 out of the products 2 will be given, and the third one will be given as a blank. So remember, whenever alkanes undergo cracking, you will get alkane and alkene molecule. Here, spelling mistakes, right? And if only alkene, the other product will be hydrogen. Now, this breakdown of larger molecule into smaller molecules, that is known as cracking. So if we have this molecule, let's say C12H24, and I get C8 and H18, what should be the another product? Only two. So break down into two molecules. So as I have seen here, 8 carbon atoms and the 12, the remaining are 4 carbon atoms. So that should be C4 and hydrogens 24. So 18 I have taken. So how many left? Hmm. Yes. Oh, that should be 16, right? 26 according to the general formula of. So the remaining hydrogens C4 and H8. Is it clear? It is an
Yes,
alkane
sir.
and it is an alkene, right? Now, next thing, we can perform this breakdown of larger molecules into smaller molecules by heating them, right? So breakdown means the breakdown of the bonds between the carbon atoms. So if we break down them by heating, we call it thermal cracking, right? So heating large molecules to a higher temperature, then it is called thermal cracking. But we have to look other possibilities as well, that heating that needs a large amount of fuel. So how can we reduce our cost? So if we use catalyst, then what is the benefit of using catalyst? Then we have to heat less. So that will save our cost of the fuel. So then heating those large molecules in the presence of a catalyst, that will definitely save our cost of fuel. So less heating is required, and it will also break down the larger molecules into smaller molecules. So the breaking down of these large molecules in the presence of catalyst is called catalytic cracking, right? So, two ways by which we can break down them into smaller fragments. So, which type of questions will be given? That the reactant molecule will be given, equation, one of the product will be drawn, and the next will be asked the second product. Or if three fragments, then two of them will be drawn, and the third one will be left blank. So alkanes break down into alkane and alkene. So these structures can be drawn, even some questions. So now let's see this in our book, this topic of cracking here. What is actually cracking? It's breakdown of molecules into smaller ones. So we can break down by in the presence of a catalyst, which is called catalytic cracking, right? So zeolite is one of the catalysts which is used to break down these molecules, right? So look at this. Here we have drawn a molecule with 10 carbon atoms and broke down into three smaller fragments. One of 5 carbon, total 5 and 3, 8 and 2, 10 carbons. And as you can see, this one is alkane, this one alkene because of carbon-carbon double bond. This is also an alkene, carbon-carbon double bond. And we are performing heating it up to 540 degrees Celsius in the presence of a catalyst. So alkane, alkene, and alkene are the products. Here you can see same, but now the product reactant is broken down into how many products? Alkane, alkene, and alkene, same molecules, two times. So total same number of carbon atoms and hydrogen atoms. Is it clear? So several products form when decane is cracked. What is actually decane? This is the molecule with 10 carbon atoms. The naphtha fraction. Now the question arises, what is naphtha? Naphtha is actually a fraction of those organic compounds which we get from petroleum. Actually, it contains all those compounds which have a carbon 6 to carbon 10, right? So you can say that hexane, heptane, octane, nonane, and decane, they are actually the part of this fraction which we get from petroleum. Is it clear? So many other molecules too. So cracking part of naphtha fraction leads to a big mixture of products. So you can see mixture of products are formed like ethene, like hexane. Here you can get ethene and propene even, and pentane. Some different types of products are possible. Is it clear? And why we carried out to actually fulfill the demand of our daily life. So the small, large, less useful compounds are broken down into more useful compounds. Is it clear? Now look at this. Remember, this is very important regarding these ethane that is broken down. Okay, later on we will discuss about ethane. Why we crack, that is very important. It helps to make the best use of petroleum to meet the demand, right? And it also gives alkenes, which are carbon-carbon double covalent bonds. So as we said, carbon-carbon double bonds like this, ethene. So in our next class, we will discuss about these alkenes and then we'll discuss their properties as well. Is it clear? Any question about these this topic?